Okay, so in this video, we're back to our orbital simulator, and I want to show you just the conditions that happen when we get both these solar and lunar eclipses. So here, of course, is the sun, and here's the Earth, and here's the moon right here, and you know, it's a little small on the scale, but you can still see the dynamics anyway. So let me just slow everything down, and what I'll do is I'll just sort of hit go here. We're not too concerned with the orbits or the force of gravity, some of the other things we've used this for, but here we go. So if I run this, and you can just sort of see the usual dynamics happening, but then what will happen right about here? You can see right here, here's the sun, and the light rays are coming across, trying to illuminate the Earth, but the moon is in the way. So this is the condition for a solar eclipse, where it's possible that if you are in this position of the Earth right here, the rays from the sun are going to get blocked by the moon. And you'll get this shadow, or you'll be in the shadow of the moon, or see this sudden darkness. Likewise, if I keep going right there, remember that we rely on the sun's light in order to see the moon. So light from the sun here has to go hit the moon and reflect off so we can see it. But in a case like this, the Earth has moved in the way, blocking rays that would otherwise hit the moon. This is called a lunar eclipse. So you see, it's really just a matter of simple geometry, or straightforward geometry. Geometry is never simple, but when these objects just sort of block each other relative to the sun's light. So as we keep going, one more time, there could be a solar eclipse right there, and there could be a lunar eclipse right there, and that sort of thing, and it goes on and on. So that's sort of what I'm talking about. Planets blocking the light relative to one another, or excuse me, the Earth and the moon blocking the sun's light relative to one another. Okay, so to wrap up this introduction to eclipses here, I wanted to say one more thing about this scenario right here, the lunar eclipse, when the Earth moves in the way. So it turns out the focus is the moon here, so what happens then? Is that sort of a question? What sort of happens? When the light gets blocked by the Earth, does it really mean that the moon here is going to be in total darkness? Well, actually what happens, believe it or not, is related to question number 14 that we have. So remember, we have these questions that we're working on getting answered here. The lunar eclipse involves question 14, and what question 14 says is, why does the moon appear red during a full moon lunar eclipse? So this is the lunar eclipse scenario right here. So it turns out that the moon doesn't go dark, but the moon takes on this reddish look, believe it or not, in this configuration. Now we have to talk about light a little more, which we'll do in some future lectures, but at the moment this is the setup for question 14, but we don't quite have the tools to answer it yet. The other question that we need to sort of discuss here in 29 is question number 29, which says, why don't we see solar eclipses once a month? So what that one's referring to is, if I go back to this diagram up here and sort of grab the Earth like this, or excuse me, grab the moon like this as it orbits, then if we saw an eclipse here, and we know it takes a month for the moon to move around the Earth, bang, would that be another eclipse a month later? Then would that be another eclipse a month later? And a month later? And a month later? So why don't we see these every month? Why aren't we used to always going out, say, every month and seeing these things? In fact, these eclipses are rather rare. So those are some of the questions that are upcoming that we'll have to answer.